You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
Yesterday, U.S. President Joe Biden welcomed Philippine President Ferdinand R. Marcos Jr. to the White House. One of the results of this meeting was a reaffirmation of the U.S.-Philippine alliance, the United States' oldest alliance in the Indo-Pacific region, since 1951, in fact. Along with this reaffirmation came a number of new initiatives and lots of signed paperwork. One of those, the first ever U.S.-Philippines Civil Space Dialogue. We'll tell you more about what this means coming up.
T-minus 20 seconds to LOS speed rest. Go for deploy. Roger, roll.
Today is May 2nd, 2023. I'm Maria Varmazes, and this is T-minus. More on the U.S.-Philippine Joint Statement on Prioritizing Space. The FAA is getting sued over Starship. The National Security Space Launch Phase 3 strategy is getting some heat. And you can own a part of Virgin Orbit. Literally. And a conversation between T-minus executive producer Brandon Karpf and NASA Deputy Project Manager Thomas Kacpura on lessons NASA has learned through commercializing satellite communication services. Stay with us. And here is your intel briefing for today. Back to our story about the meeting between U.S. President Biden and Philippine President Marcos yesterday at the White House. Lots of outcomes for the U.S.-Philippine alliance, but one of those highlighted in a press release from the White House was titled simply Space Cooperation. It's not terribly long, so I'll read the entire thing for you. The United States and the Philippines will strengthen bilateral cooperation on space situational awareness and the use of space for maritime domain awareness, including through the first ever U.S.-Philippines Civil Space Dialogue. The countries will collaborate on the use of space-based technology in areas of disaster management and emergency response, healthcare, mapping of resources and accessibility, pollution monitoring, deforestation, land use and infrastructure planning, and maritime awareness. The leaders welcome the strengthening of bilateral cooperation on the Landsat program, including the possibility for the Philippines to download imagery directly from Landsat satellites to its ground stations. Okay, so why is this significant? Well, remember what I said about the Philippines being the oldest ally of the United States in the Indo-Pacific region? So let's put on our strategy hat for a second. The Philippines is part of what U.S. military and foreign policy strategists call the First Island Chain, which is the primary line of defense in counter-China contingencies and the staging line for responding to an invasion of Taiwan. The First Island Chain refers to a series of archipelagos in the Asia-Pacific region, which form a natural strategic barrier to China. The concept of the First Island Chain is part of a broader containment strategy that aims to limit the expansion and projection of power by potential adversaries in the region, and also forms a strategic staging zone for launching counteroffensives in the event of a war in the Western Pacific. So one could infer that increasing interoperability for space domain awareness and maritime domain awareness is specifically a counter-China capability in the event of a war in the Western Pacific. So to this end, the joint statement from Presidents Biden and Marcos noted that both countries will be prioritizing and strengthening their space capabilities, and that the first U.S.-Philippine civil space dialogue will take place later this year. And we'll be sure to update you when it does. Staying in the Pacific for a moment, the South China Morning Post is reporting that Chinese satellite internet startup Galaxy Space has announced they'll be providing broadband connectivity for military hypersonic drones and aircraft. Last March, Galaxy Space launched 6 experimental satellites to low Earth orbit, or LEO, as a proof of concept that they could maintain continuous bidirectional data transmission between the satellites and a fast-moving terminal for about 25 minutes. The company says that by extrapolating from their successful demonstration last year, they believe their satellites could provide broadband connectivity for hypersonic drones and aircraft traveling up to Mach 25, though they also agree with the Sagan principle, namely that extraordinary claims require extraordinary evidence. Now, if you've been following the news about SpaceX's Starship, this development probably comes as no surprise. A number of environmental groups are suing the Federal Aviation Administration with a number of complaints. First, the environmental groups are saying that the FAA biffed their environmental review of the Super Heavy lift vehicle prior to its initial flight test that spewed sand, debris, and dust all over an environmentally sensitive area. Secondly, the groups also allege that the FAA didn't do its due diligence about Starship launching from alternative areas, namely the Kennedy Space Center. And also, the groups are suing because of the FAA's extended closure of highway access to adjacent public beaches, whose free access is guaranteed by Texas state law. Jared Margolis, senior attorney at the Center for Biological Diversity, said this: federal officials should defend vulnerable wildlife and frontline communities, not give a pass to corporate interests that want to use treasured coastal landscapes as a dumping ground for space waste. We actually reached out to the FAA for comment, and for their part, the FAA responded with this: the FAA does not comment on ongoing litigation matters. The chair of the U.S. House Armed Services Committee, Representative Adam Smith, has questioned the Department of Defense's National Security Space Launch Phase 3 strategy. Smith says the 2-lane plan, which we've covered a whole bunch of times in previous episodes of this podcast, doesn't give fair funding opportunities to commercial companies selected for procurement. The 2-lane approach for procurement is due to come into play in 2025 and was designed to allow smaller launch vehicle manufacturers to compete for bids in the Track 1 option. Smith says that companies that compete for Track 2 options would qualify for launch service support funding and annual incentive fees of up to $20 million, and would also be allowed to compete for Lane 1 missions, giving them even more funding opportunities. 51 Guard Adjutant Generals have petitioned the White House for a dedicated Space National Guard. The generals urged President Biden in a letter to reverse a decision by the Office of Management and Budget that would establish an alternative structure. The petition letter warned that the directive to transfer current National Guard space missions to an unestablished space component will create a 7 to 10-year gap in the capabilities of Air National Guard space units. The Office of Management and Budget say that creation of a separate Guard branch for space would cost up to $500 million annually and would not provide any new capabilities. The National Guard Bureau has estimated the one-time cost to be $250,000 for heraldry, uniform items, and the transfer of existing manpower and resources from Air Force National Guard space units to a new Space National Guard. Hey, is anybody looking to buy a souped-up 747? This could be your chance. An order has been approved in Delaware setting up bidding procedures for the sale of Virgin Orbit's assets. And this could also potentially include the sale of the company's main aircraft, Cosmic Girl. Buyers have until May 4th to submit their interest, with formal bids due May 15th. If the process results in more than one qualified bid, an auction will be held on May 18th. Virgin Orbit has been approved to continue operations in a reduced capacity during the Chapter 11 process. The British government has launched a commercial Earth observation, or EO, pilot program. The Geospatial Commission, part of the Department for Science, Innovation and Technology, launched the pilot for a number of UK public sector bodies. Viscount Camrose, Parliamentary Undersecretary of State, Department for Science, Innovation and Technology, says the program will test how the UK can drive innovation in the heart of government service delivery, from effective disaster response to enhancing the science behind the understanding of land use change. Staying with Earth observation for a moment, Synspective and THAICOM are partnering to deliver imagery and data to the Thai government. The deal will see Synspective supplying synthetic aperture radar, or SAR, satellites to THAICOM. The benefits of SAR imaging include assessment of environmental changes or damage caused by natural disasters, monitoring infrastructure such as roads, bridges, and buildings for damage and displacement, as well as reviewing agricultural land and crop growth. Supply chain issues seem to be easing up this year, but companies are continuing to release news of financial hits. For example, satellite tech company SatixFy says that they experienced a 50% drop in revenue in 2022 due to supply constraints and cancellations. SatixFy went public in October through a special purpose acquisition company, or SPAC, merger, which added $5.5 million to administrative expenses in 2022. CEO Ido Gur says the company expects to release new products by the year's end, including 2 flagship space-grade ASICs and an in-flight connectivity terminal product, which they hope will boost revenues. Say, do you love watching rocket launches? Love the great outdoors? Like the peace and quiet of solitude? Like really, really like the peace and quiet of solitude? Then do we have the job for you? Alaska Aerospace Corporation is looking for a new CEO to oversee operations at the Kodiak Pacific Spaceport Complex. You can read more about that position along with more stories at our selected reading section on our website, space.n2k.com. And that is our Intel briefing for today. So, hey T-Minus crew, our audience is growing rapidly, and that is big thanks to you. So if you're just joining us, please be sure to follow T-Minus Space Daily in your favorite podcast app. And also do us a favor. Please share your favorite episodes on social media. It helps professionals like you find the show and join the crew. You can find our social media profiles in the show notes and at space.n2k.com. And coming up next is T-Minus executive producer Brandon Karp's conversation with Thomas Kacpura from the NASA Communications Services project team on lessons that they've learned through commercializing satellite communication services.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
At a recent conference, T-Minus executive producer Brandon Karp met with Thomas Kacpura, deputy project manager at NASA Glenn Research Center, and he's specifically working on the NASA Communications Services project team. They talked about NASA's new approach to contracting and helping private industry commercialize and go to market, and specifically what NASA can do to help launch a market and make businesses successful and not just build new technology. Lots to take away from commercializing satellite communication services, so here's their conversation.
So the last big thing that I did was I was the communications lead for the SCAN testbed. The SCAN testbed tested 3 software-defined radios in space. And so I am inducted into the Space Technology Hall of Fame for flying the first space Ka-band software-defined radio.
When we say Ka-band, what does that mean in terms of capability and technology?
Ka-band is one of the higher frequencies, and that's what we use for our high data rate return. The missions that we fly produce a lot of data. And so one of the best ways to get that data back down to the ground is the use of Ka-band, which can offer much higher data rates than using some of the radios that are much lower frequencies.
When we think about data communications using the space architecture, what's the state of the industry right now in terms of the state of the art and what we are currently using?
So if we look from the NASA technology right now, our tracking and data relay satellite system, or TDRS, is what NASA uses. That technology now has on the third generation, and it is, for government users, it's the state of the art. What we're seeing now, though, is that the commercial industries are starting to develop the technology. NASA's actually looking at doing it too. They're using optical as well as the radio frequency types of communications. And optical in the long term offers much higher data rates than what you can use with conventional RF technologies.
When we look at your work at the Communications Services Project, what's the goal with that new research project out of Glenn?
The CSP project, Communication Services Project, is a extension of what NASA has done with the Commercial Orbital Transportation System project, the COTS and the Commercial Crew, where they were looking to be able to develop commercial technologies for spacecraft. Rather than NASA actually owning and launching and doing everything for the spacecraft, they had commercial industry go out and develop those technologies and ultimately be able to buy those as a service. And so we've adopted the model that COTS and Commercial Crew does, and now actually the commercial LEO destinations, the CLD, where they're looking at commercial space stations. CSP is looking at commercializing the communications to spacecraft rather than us owning and operating the systems all ourselves. We're looking at going out and buying that as a service.
And how's it going? Are you buying systems right now?
So we are in the phase 2. So in our formulation phase, we looked at what the mission needs were for future missions, and we also looked at the industry capabilities. And we formulated an announcement for proposals to demonstrate those capabilities. We're currently in phase 2, and in phase 2, what we're doing is we've partnered with industry with funded Space Act agreements with 6 different companies, and these 6 different companies are doing capability development and demonstrations for us, where we've invested $278 million. Commercial industry has put $1.5 billion into the effort, and working together, we're doing these end-to-end operational service demonstrations with their existing constellations, extending that service out to spacecraft and having a mission operations center on the ground. They're doing a full end-to-end demonstration of that commercial capability.
What are some of the key technical as well as maybe process hurdles that these companies need to cover in order to be successful?
We want to understand the operational constructs of how their systems will work. So the technical details of how their constellations will point the signals at our spacecraft and we'll be able to intercommunicate with them. That's the aim of those demonstrations. And the performance validations is the next piece of it, because not only do we want to understand how it will work, but how well will it work. We've left the technologies up to the companies in order to recommend, but we want them to be able to demonstrate that you've got end-to-end communications from the spacecraft all the way back down to the ground at a mission operations center, and the signals from the mission operations centers going through their constellations, getting them back to our spacecraft with near zero delay, reducing that latency so it's a low latency communications. We start to look then at what's the performance validations of the services that they've proposed, making sure we've got a good handle on that. So those are the technical side of it. The business side of it is just as important to us as the technical side, because it's an aim of the CSP to make sure that these services are not just demonstrated, but at the end, they have users of the services. So from that end, we want to make sure that they've got a business model that closes. That is, they've got enough customers to sustain the service, and they've got other customers other than NASA. And make sure that that business model holds well. And then the last piece of it is we want to understand their acquisition approach. Just as you go out and buy a service for your internet or cable, whatever it is, we want to make sure that the service level agreements that they have developed they truly have thought about the customer needs and offer a service that will meet the majority of the customer needs and look at it for how they would meet it for not just NASA needs, but all their customers. That's kind of the four tenets and the four hurdles that they have to get through as they work through these capability development demonstrations. They're roughly about 4 years in duration. And we've got funded Space Act agreements in order to give them progress payments quarterly, roughly. They have milestones that they need to meet, and they satisfactorily show us that they've met those. We're trying to make sure we understand how they would offer a service for all of their customers, not just NASA.
So when you think about customers and commercialization, who would be users of this type of technology and for what purpose?
Anybody that flies a spacecraft would be the potential user of the service. And that would be, NASA, we have lots of missions. When we look at other uses of that, there are other government agencies. There's a lot of other government agencies that we've invited them as part of our commercial services user group. Any branch of the government that flies spacecraft, they also can use these services. Last side of it is the commercial side of it, because there are a number of commercial entities, and as the government has really tried to commercialize low Earth orbit, there's now many more commercial customers that can use these services as well. We want to make sure that the services will meet the needs of any commercial users going forward.
As these companies work to develop this capability, prove out their technology, their platforms, and work with NASA through this process, to what extent is security a consideration here?
Good question. Because security has been very much an integral part of what we're trying to do, and in fact, it's been specified as part of the demonstrations. In regards to the cybersecurity perspective of it, now the fact that you've got data going to spacecraft and you're getting that data coming back off of the spacecraft and it's going through a commercial network, anytime it's going over those commercial systems, there needs to be the appropriate security measures in place in order to be able to communicate through a spacecraft. And that's a big part of the demonstrations is that we want them to show us the details of their security approach and how they're developing the cybersecurity approach, not only for NASA, but how they would do it for their own customers. Big part of some of the trade spaces that the companies are making is that whether they directly adapt the one-size-fits-all for their part for each one of their customers, or whether they're going to have this kind of a customizable kind of approach in their service level agreements. That's what we get in the acquisition approach. We understand what their service level agreements is and what's their security approach that's associated with that. We want to understand what that approach is. That being said, there are certain requirements for cybersecurity that we've said, hey, here's how NASA currently does things. And then we've asked them to demonstrate that. And we also want to have an opportunity, if we want to do some of our own independent testing, whether it's NASA or we've got a third party doing some independent testing. As part of the demonstrations, we've wrote that into the agreement as well. One of the big challenges will be is that space is looking very much at going from typical hardware, which we fly into space, to more reprogrammable systems. How do you come up with an appropriate cybersecurity approach, knowing that NASA missions run our missions until the spacecraft dies? So some of our missions, while it might be designed for a year, 2 years, 5 years in life, we'll run them and they can last 10, 20, 30 years until the spacecraft fails. Having the right adaptable approach to that's to me is one of the big challenges as to, hey, what's the right way to implement the cyber secure approach and make sure that it not only meets the security perspective, but can meet the long mission life. That's going to be one of the big challenges that we see going forward.
We definitely look forward to catching up as more information comes out and as you start testing these technologies. Tom Kacpura, thanks for joining us today.
Thanks for the opportunity to talk with you today.
Thanks again to Tom Kacpura for taking the time to speak with T-Minus. We'll be right back.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCorps Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
Welcome back. The dreams of the 1800s are alive in space. Earlier this month, aboard the Tiangong space station, the Chinese National Space Administration announced the very first successful space-based test of a Stirling engine. Yes, you heard that right. The Stirling engine, patented by Scottish engineer Robert Stirling in 1816, has now had its first successful space demo thanks to China. Now, you've probably seen a Stirling engine at work before without realizing it. They're very quiet, very elegant, and a bit steampunky, and they basically harness the power of thermodynamics to convert heat to electricity. So heat from a given source moves a magnetic piston, and then that piston can then be used to convert the energy to electricity. Given a decent differential between hot and cold, you can get a Stirling engine to run. CNSA said their Stirling engine demonstration aboard Tiangong performed beyond expectations and provided a stable electric current. Stirling engines have had kind of limited industrial application here on Earth, but both CNSA and NASA have seen lots of potential for these 19th century engines in space. And in this case, China got to it first. I wonder if Robert Stirling ever imagined his invention would be in low Earth orbit one day. Anyway, that's it for T-Minus for May 2nd, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Caruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazes. Thanks for listening.